Alright, so at this point we're working with the Drawbot, and we should have a left motor and a right motor instance. And so if you were to put them both right here with the left motor and the right motor together and run this, you should see it move forward. Okay, and so ideally that's the state of things. And the next step is we're going to actually modify this so we can tell it how far to go. So we're going to control it by saying go this many millimeters forward. Okay, so we're going to start by making some tweaks just to make this a little bit more runnable. So first of all, make sure you have a main.py, and we're going to go like this, I think. Okay, and then from here we're going to do something similar. Like that. Okay, and then in run we'll add our try and accept block. Okay, and then we will in here we're going to say we'll have to do a stop function. Self.stop. Okay, so let's start with that. So let's create a stop function. And so we're going to say def stop self. And what we're going to do is we're going to grab both of those and copy them in here. And then we have in our stepper module, we have the disable. And so we're going to, in the stop function, we're going to do the disable. And basically what happens is with the stepper motors, they, as long as they're energized, the motor's going to hold its position. And when we do call this stop function or this disable, it de-energizes those coils, and then the motors would actually be able to spin a little bit more freely. Okay, so the coils wouldn't be holding those positions anymore. Okay, so we've got that stop function. Now let's go ahead and make a forward function. We'll go after that. Yeah, we'll do it. And so what we're going to do here is we're going to tell it how far to go in millimeters. Okay, and so we're going to go forward a certain distance. And so basically we'll control the motors by saying go forward this distance, and then we're going to use this for loop like this. Okay, something like that. Okay, and so instead of using steps per rev, we're just going to say total steps. Alright, let's do this to be this as well. We'll go like that. Okay, and so we have to somehow get from our distance calculation to our total steps. So we're going to say total steps equals, and we're going to say distance to steps. And we're going to pass some distance millimeters like that. Okay, so we're going to create a function that will do that calculation for us. Okay, so let's come over here and let's write that function. Distance to steps self, and then distance millimeters. Okay, and so now we have to do a calculation in which we return total steps. So total steps, we're going to calculate here. Okay, and so let's think about how circles work. The distance around the circle is the circumference. This would be the wheel diameter times pi, right? We'll use math dot pi, and let's go to import that here. So we're going to say import math. Okay. And so we got our circumference there, and now we're going to say, okay, so a circumference is one pass around the wheel. Okay, and basically what we need to do now is we're going to figure out how many total rotations our distance is of that circumference. And so we're going to say total rotations equals circumference divided by, and then we need to get the, let's see, the distance in millimeters. Actually, it should be the other way around. So we're going to take the distance in millimeters and divide by the circumference. If our circumference is like 100 millimeters and our diameter is 100 millimeters, that would be one total rotation. And so now we're going to say total rotations, and we're going to multiply that by the number of steps for a single rotation, which is steps per rev. Okay, so the last thing we need to do is we actually need to know what the diameter of our wheel is. So let's come over here, and we're going to put that in. So wheel diameter will be equal to, and then you're going to have to come in and take your Drawbot and actually measure that wheel with the calipers, okay? And it's going to be something millimeters. So we'll say it's 73.4. So you need to actually measure this and put your value, okay? And then I believe this should work. So now let's get rid of this and this, and we're just going to say forward 500, and this will make it go forward 500 millimeters, okay? And then you run it, and let's see, it's not working. Make sure it's working. Okay, so name for, oh, we're going to go self dot forward. There we go. Okay, line 27. So I got some bugs here. Distance. Oh. There we go. I put the self keyword there. Run. There we go. So now you can see it's going forward, and essentially what the next step is to calibrate this. So I'm going to tell it to go forward like that, 500 millimeters, and I start it and run it, and it should go exactly 500 millimeters. And I need to adjust this number here up or down to get it to be exactly 500 millimeters. So if it's going too short, like not going far enough, then this number is too big. And if it's going too far, then this number is actually too small. And so you're going to measure that and you'll update it. And then you'll also create a reverse function and test out that reverse function. And basically, in order to go reverse, and I guess we'll just do it here together, we just want to set that to negative for backwards. And then if we try reverse, we should see those wheels going backwards instead. Okay, and so this is the next step there. And so the most important part here is to make sure you get this calibrated so that it goes exactly 500 millimeters forward, because we need to be able to control the distance exactly. And this is going to be also important when we start doing turns later, that we get this wheel diameter calibrated correctly. Okay.